Assalamualaikum and a very good day to you all. In this video, I would like to discuss on how to sketch absolute functions and finding their domain in range. Yeah, so let's get started. Now we look at the coefficient of the absolute value. Sorry, the absolute value symbol over here in front is 2, so it must be a V shape. Yeah, so when we next we are finding the point over here. Okay, now how to find it? Easy. To get okay, 2 plus x, we equal everything inside the surd become equal to 0, so we have minus 2. And how to get y? Y is getting everything whatever here, actually this one plus 0. Okay, so 0, so the point is at minus 2, 0. Okay, afterwards we need to find the y intersection or x intersection, but it's better if we sketch roughly and get some idea where the function is located. Now our reflection point here, minus 2, 0 is somewhere here. Okay, this is minus 2, and then our graph is a V shape, so it's going like that. So clearly we no longer need to find x-intercept because the point itself is the intercept. Now what's left is finding this. Okay, so we want to find y-intercept when x equals 0. So y equals 2 plus 0, so 2 is 4, so therefore it's a 4 over there. And then don't forget to name your function. Yeah, now so from here let's find out what the domain of G. The domain of G is the all x values that can be inserted in the function. So if we have a vertical line from the left hand side here, it touches, okay, from minus infinity, and then as soon as we move it to the right side, they will touch at every point. So it means that every x is correspond to the function. Yeah, so it's a real number. And now what is the range? The range of G is the all possible value of y. Okay, just now when we do vertical, this time we are doing horizontal line. Okay, actually this horizontal line is not compulsory. It's just my way of finding the range. Okay, now remember, range is all the possible value of y, so that touches the function. Now these y here are all y negatives, and as you can see, it doesn't touches the chocolate graph that we made, the chocolate function that we've made. Okay, but as soon as I move at y equals 0, okay, x-axis, y equals 0, it start touching up until positive infinity. Therefore it means the range started from 0, including, okay, because 0 is a part of the function, y equals 0 up until positive infinity. Okay, so that's for the first one. Let's go to the second example. Now, okay, maybe it's better if we rearrange it, okay, and put the absolute value at the back, at the front, and then the number plus 1 over there. Okay, now what is the shape of the absolute value? Is a A shape. Okay, not a V shape because it's for positive coefficient of absolute symbol. Okay, now how to find the point over here? Okay, it's easy. This one, x minus 2 equals 0, x equals 2, and the value of y is just take everything over there, so therefore the point is at 2, 1. Okay, now where is 2, 1? Way over there, and then A shape some more. Okay, tak apa. Okay, maybe something like this. Okay, now 2, 1 is somewhere here. Okay, 2 1. Okay, maybe green lah. Okay, the green. Okay, and then the function is a A shape. So maybe from the point I extend it like that, and then I extend it like that. So it's like A shape. But okay, but you see here, the line is closer to the origin. So we need to find the intersection because there might be 3 other possibilities for the line. Okay, like the extra 2 that I've made on the screen. Okay, what is the differentiate between them? It's the Y-intercept. Over here, the Y-intercept is negative. Over here, the Y-intercept is 0. Over here, the Y-intercept is positive. So by finding the Y-intercept, we know which one is the correct one. Okay. Now, a Y-intercept is when x is 0. So y equals 1 minus 0 minus 2. Oh, sorry. So absolute value symbol. So 1 minus 2, okay, is minus 1. So we are expecting a minus y-intercept, which is over here. So we can get rid of these 2. Okay. And then we label that chosen one as minus 1. Now, as you can see here, we have these 2. Oh, sorry. Forget to label this one. This one berapa? 2. This one 1. Okay. Where was I? Okay, this one. Okay, now you see the one that the 2 places I've highlighted in yellow. These x intersection we need to find as well. So x intercept is when y equals 0. So 0 equals 1 minus x minus 2. And then I move it over there. X minus 2 modulus equals 1. So from here, we break it into 2. X minus 2 equals 1. Or minus x minus 2 equals 1. So x equals 3. Minus x plus 2 equals 1. And then x is 1. Okay, so we have 1 and 3. So clearly this one, the left one is 1 and the right one is 3. So all functions are labeled, oh, I forgot to F again, hx, okay? Forgot to label the function. So we need to label the function, label the x's, label the y's, label the numbers, and the intersection related. So this is the how we are going to sketch them. Oh yes, the domain and range. Okay, now domain of h, domain of h as usual are all the x's. So you see here, from here, if we do the line, okay, it touches all the way from left to right. So all x can be put inside the function. Okay, and then the range of h is value of y. Okay, if we start here at y equals 2, it doesn't touches the function. But when we move the line downstairs, I'm sorry. Tak apalah. Okay, it starts from minus 1 over here, and then up until infinity down there. It endless, because the function, the graph go still ongoing. It's just that we limit our view. So it's from what's that? Okay, minus infinity, okay, up until 1, okay, included. Okay, so let's move on to the third example. Okay, okay, this one, I'm sorry. Excuse me. Okay, now this one positive, not the equal sign, the number in front of the absolute value is a positive, so we are expecting a V shape. Now the V shape has a point here. We want to know what is the coordinate. Easy. X plus 3 equals 0, x minus 3, and then minus 2, we take everything minus 2. So it's minus 3, minus 2. So the point is at this place mentioned. Now, so I do like that lah. So we have here minus 2, we have minus 3. Now we are expecting, this is the point, okay, and then our function is a V shape. So from the left hand side is like that, only one possible x-intercept. But when we extend it over here, it might go here or here, or the first one that I've made. So we need to find which one is correct. We will know which one is correct one when we get the y-intercept. So y-intercept happens when x equals 0. So y equals 0 plus 3 minus 2, which is 1. So we are expecting a positive y. So maybe I need to adjust the scale. Push a little bit higher. And then let it go through a value of 1. So where is 1? This is 1. The y is 1, but we haven't find the x-intercept over here. So x-intercept happens when y equals 0. So 0 here, x plus 3 minus 2. Bring 2a over there. 2 equals x plus 3 modulus. Then we break them into 2. So 2 equals x plus 3, or 2 equals minus x minus 3. Okay, and then I have x minus 1, and x I have minus 5. So minus 1 obviously here, and minus 5 is obviously here. So this is the function. Okay, now let's write what is the domain and range. Okay, range M. Okay, now domain as usual is all possible x's that correspond to the function that can be put inside the function. So we trace a line here. It starts from minus infinity way over there, okay, up until it doesn't end actually. Okay, so it's a real number. Now how about a range? Okay, maybe I use different color lah. Okay, range. Now the function started, the y value, the minimum y value for the function is minus 2, and then it goes towards until infinity. So minus 2 to infinity. So minus 2 until positive infinity. Minus 2 is close because it is a part of the function. Yeah, that's it. So that is the domain and that is the range. Now let's move on to the last example. Nx equals x plus 4 modulus plus 3. Now first, the shape. The shape is a V shape. Good. We have the point we want to find. Now how to find? X plus 4, everything inside the modulus equals 0, x minus 4. Okay, next. Wait, okay. Now we want to find the y, just take everything here. So therefore, the point is at minus 4, 3. Then minus 4, 3, left there, up there. Okay. Then going up. Okay, so like this lah. Yes, x, y. Okay, where is minus 4, 3? Minus 4, 3, somewhere here lah. Okay, so this one is minus 4. This is 3. Okay. I just remember I didn't label the function. What is the name? mx. mx. Okay. Just realized suddenly. Wait. Yes. Correct. Okay. Sorry. Now, okay. So we have the point there. The point, and then it's a V shape going upwards. V shape obviously like going upwards, right? Okay. Now from here we have only y-intercept. So we no need to think about x-intercept because there's not possibly exist. Okay. So don't bother to find the x-intercept. So just y-intercept. Okay, when x is 0. So y equals 0 plus 4 plus 3. Okay, then 7 lah. So this one is 7. Nx. Nx. Okay. Is there anything else? I don't think so. Okay, now, so let's find the domain and range. Okay, domain of n. Okay, domain is all the possible values of x. Now, if we start from the left, from here, the function here, the line here actually extends towards from minus x minus infinity. So it's from there up until from there. All the x's are correspond to the function. Okay, so yeah, so the answer for that is real number. Or you might want you want to write it like this also can, no problem, same thing. Now, how about the range? Okay, the range is all possible value of y that correspond to the function. So let's say we sketch a horizontal line. So as you can see here, the blue line doesn't touch any of the function, but it will when y equals 3. And the trend continues up until positive infinity of y. So 3 until positive infinity. It's supposed to be open bracket. Okay, I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.